Hello and welcome to our second video in chapter 21 on the lymphatic system. We are going to cover both section 21.2 and 21.3 in this video. So first is section 2 on the overview of lymphoid structures. So we classify the lymphoid structures as either being primary or secondary. The primary means that it's involved in some type of formation and maturation of the lymphocytes, those being T cells. So this is going to consist of our bone marrow, which consists of a few of our flat bones and areas of our long bones, but we're going to talk about this more in section 3. And the thymus, which you can see overlying the heart. And this tends to be bigger when we are younger and starts to atrophy as we get older. All the other lymphoid structures are going to be classified as secondary lymphoid structures because they are not able to form these lymphocytes, but they do house them and other immune cells. So this would include our lymph nodes, which you can see in the area such as the axilla, in the cervical region, or the groin. We'll include the spleen here as well. The tonsils that surround the area in the oral cavity and the posterior to the nasal cavity, and also lymphatic nodules that may be embedded within certain tissues. And this includes MALT, which stands for our mucosa-associated lymphoid tissue. We're going to dive in a little bit deeper on this in the coming slides, and notice that these are all going to be sites where we can initiate an immune response because our lymphocytes are housed within it and we have our other immune cells in that area as well. Now let's go into section 3 where we're going to talk a little bit more in detail about our primary lymphoid structures. So first we'll start with the red bone marrow. This is going to be located between the trabeculae of the spongy bone. That would include our skull, the ribs, our sternum, our vertebrae, our os coxa or our hip bones, and the heads of the humerus and femur. And these will serve as sites of hematopoiesis. Let's say that out loud so we can get comfortable with saying that word, hematopoiesis. And that is the production of our blood's formed elements in this red bone marrow. So we are going to be able to produce our T lymphocytes or T cells and our B lymphocytes or B cells. Then our T cells are going to migrate over to the thymus in order to become to reach complete maturation, whereas our B cells are going to stay within the bone marrow to mature there. And when we look at the thymus, we know that it is going to involve T lymphocyte maturation. We find this in the area of the mediastinum, like we said, kind of sitting on top of the heart, and we see that it is larger in children than it is in adults. It starts to atrophy because we really don't need to mature our T cells anymore. We've already gone through that process. So it gradually becomes replaced by adipose tissue. Now, as far as its structure, it is made up of 2 thymic lobes and it's surrounded by connective tissue capsule. If we were to look at the histology here, we can see that in a child's thymus, we have these great trabeculae that are portions of the capsule that subdivide the thymus into lobes and then further into lobules. And each lobule is going to have a periphery of a cortex and an inner medulla. That's this lighter area right in here. Now both of these regions are going to be lymphoepithelial, meaning we'll have our lymphatic cells in there as well as some epithelial tissue. But it's our cortex that is going to contain the immature T cells, and the medulla will contain the mature T cells. So you can think medulla starts with M, and this is where the mature T cells are. Notice how in the adult view of the thymus, we see a lot more of the adipose tissue and very few lobules.